Hi, this is Bosch. Today I want to talk about the homework 7 for 8th question. So for this question, there is two parts. For the first part, they want us to find out the ext. For the second part, they want us to find the rt1 and t2. So in this question, they already talk about some pensions process and definition for it at the beginning. So for this question, we need to use this definition and a function for the pensions random variable. So for the ext, we need to use the pension random variable function to calculate. So for probability of x equal k, which is equal e to the lambda k divided by k. This is a pensions random variable function. This is use a pension random variable function. And for the second part, we need to use sum k from 0 e to the lambda times lambda k divided by k, which is equal to 1. As we know, for this part, which is equal to 1, so we can put the e to the square in this side, which is equal to sum of infinity k equal to 0 and lambda k divided by k square equal to, because we make this to this side, so negative become positive, which is e to the lambda. After that, we need to take derivative of this two sides, which is equal to d to the d lambda times lambda k divided by k equal e to the lambda. After that, take derivative of both sides, which is equal to k times lambda k divided by 1 divided by k, and equal to lambda times e squared. After that, as we know, we want to find out the lambda, so we need to put this part, go back to this part, so we can get the lambda. Which is equal to lambda. As we know, ex equal to lambda equal to sum of k to the 0 k e to the lambda to k divided by k squared. So because we already calculate out this part, so we can use same idea for the ext. So which is equal to, because ex is equal to lambda, so ext is equal to lambda times t, so this is ext. For the second part, they want us to find out rt1 and t2. So at the beginning, as we know, if we want to find out the ext, we want to find out rt1 and t2, we still need to use the function that we calculated before. So in this part, sum of k equal to 0 k times lambda k divided by k squared equal to lambda e to lambda. This part from this part. Sorry. So we take derivative of this part first, because we will use this step for the for other parts, so I want to calculate it first. After that, take derivative of this part, which is equal to sum of k equal to 1 k squared lambda k divided by 1 k squared equal k lambda plus lambda e to the lambda, because e to the lambda take the derivative, which is equal to this part. After that, we can make this part together, which is equal to 1 plus lambda e to the square. After that, I want to make this minus 1 out, so I need to times lambda in this part and this part too to take out this negative. So which is equal to k square lambda k, sum of k equal to 0 and equal to lambda times 1 plus lambda e to the lambda. So the final answer for this part, which is equal to k square lambda k times e to lambda, which is equal to lambda times 1 plus lambda, because I put this part in this part. And as we know, this function equal to e to the x squared. So I put this step in here first. This will help us to calculate out our T1 and T2. So for our T1 and T2, which is equal to e to the x1 x times T1 times x2. After that, there is plenty of the calculation, which is equal to x T1 times x T2 minus x T1 plus x T1. In this part, I just minus x T1 plus x T1, which is 0. So I just want to use this step like this tricky to calculate the below part. So which is e x T1 times e x T2 minus x T1 and plus e x squared T2, because I just want to use this step to calculate below part. So after that, as we know, ex T1, which is lambda T1, we calculate in the first part, times same idea, ex T2 is equal to e times lambda times T2 minus lambda times T1, which is plus. For this part, that is why I want to calculate this part first, because I want to use the idea in this part. So which is equal to lambda T1 times e plus lambda T2. So which is equal to, when we make this part out, we can get lambda T1 T2 minus lambda T1 square plus lambda T1 plus lambda T1 square. This part can be 0 because negative and positive, so which is equal to lambda T1 lambda T2 plus lambda T1. So this is for the 8th question.